Hey guys, we're going to look at gas law practice problems today. As you guys get ready for your gas laws quiz or test, we'll count it however works best for you guys. But as you guys get ready for this, the best way to do that, and really the only way to do that, is to keep it really simple and really small. So I'm going to go over the gas laws with you today, and while I'm doing that, I'm going to basically teach you how you need to approach your test. Your test only has, or quiz, only has 10 questions on it. Gas laws involve just a couple of things. You know, it's gases, so it involves and the amount of it, the volume of it. So pressure, temperature, and volume. That's what we're going to be looking at today. What I need you guys to have out is a sheet of paper, like what I have right here. And then I need for you guys to have out the practice problems, and I'll get to that in just a second. You're going to also need a calculator. So if you don't have those things, a blank sheet of paper and a calculator, something to write with, then pause right now, go grab it, and then come back. This is your assignment for class for this week, so you need to make sure that you're following along. Okay, step one, we're going to write down a list of the equations that go along with gas laws. Okay, so the first one is Boyle's law. I don't care so much, you're not going to be tested over whether or not you can remember these people's names. If we were in face-to-face school, yes, you would. For this test, your test only shows whether or not you can plug things into an equation and move on. So Boyle's law is going to be P1 V1 equals P2 V2. Okay, you guys can probably figure out P is pressure, V is volume. Okay, volume, how much of something there is. Okay, there's 1 and 2, that means before and after. The second one that we're going to look at is Charles's law. Okay, and that's volume over temperature equals volume over temperature. So V1 over T1 equals V2 over T2. Okay, the third one that we're going to skip one, but the next one we're going to look at is called Gay-Lussac's. And he is P1 over T1 equals P2 over T2. So if you notice a trend here, everything is pressure, volume, and temperature. But in each one of these, there's only 2 variables. There's either pressure and volume, there's volume and temperature, there's pressure and temperature. We don't have all 3 of them working together. Okay, so in every case, you're going to be given just 2 of these things, except one of the problems on here. We're not doing the combined gas law. We are skipping combined gas law. But we are going to do the ideal gas law. Okay, so we call this the ideal, and this is the only one that has all these guys sort of combined, but it doesn't have a before and after. It's got PV equals little n RT. Okay, PV equals nRT. Okay, so do you have to memorize those? Absolutely not. No, but you do need to have this page right here written down when you guys get ready to take your test. Okay, so that's the first thing that you guys need to have. You need to have all of this written down right here. The other thing that you guys need to probably add over here, maybe on the right-hand side, are some of your units so that you don't forget. The only thing that I think might be challenging, and it shouldn't be, if you have this sheet of paper right there with you. But for most of us, the thing that we make mistakes on is we use the wrong unit to figure out. Like if it says kelvins, for example, don't put that in pressure. What is kelvins? Kelvin's temperature, right? So remember that P equals pressure, V equals volume, T equals temperature. Okay, and the way that we measure those things, pressure is going to be atmospheres. Sometimes it's torrs, T-O-R-R, but I think for today we're going to keep it with atmospheres. Volume is how much of something you have. So for the most part, it's going to be milliliters or liters, a form of liters. Temperature is going to be Celsius, degrees Celsius, or K for kelvins. We don't say degrees Kelvin, we just say Kelvin. And then the last thing is standard temperature and pressure. Standard temperature is 0 degrees Celsius or 273 Kelvin. one really easy thing about that is if you have to go back and forth, you just add 273 to whatever degree Celsius you get. And we talked about that last week, but for example, if it's 10 degrees Celsius, you just add 10 plus 273. So it's a very easy conversion. It is not like Fahrenheit at all. Standard pressure, the pressure part of that, this is temperature, obviously. The standard pressure is 1 atmosphere. Okay, so at sea level, the pressure is 1 atmosphere, and then the temperature would be 0 degrees Celsius or 273 Kelvin. Okay, so those are the most important things that you guys probably need to know as far as that goes. And then we'll come across any more as we go through these problems. So as you guys are taking your test, you need to have this entire sheet right here, every bit of it. Sorry, I just cut you off there. You need to have every bit of that with you. You need to have this with you when you take your test, and you need to have a sheet of scratch paper that you can write all over. And then when you pull up your test, you should be able to go in. The other thing that you're going to need to have, and I only have this big one here, but you need to have your calculator with you. It's just basic multiplication or division for this one. So you guys can, there's no scientific notation. So if you need to use your phone for this, that's fine, or the one that's on your computer, that's totally fine as well. Okay, the second thing that you guys need to get out is going to be this sheet right here. It's called the Gas Laws Mixed Review Practice Problems. It has the same title if you look at it in our eClass page. If you don't have it printed, then that's fine. You just need to write these problems down. But the second thing that I'm going to teach you guys to do, and I expect you to do it, and I expect you to upload this to eClass, as are the directions for this, you're going to need to follow my directions on how we go about solving these problems, and that will stop you from having any issues as we go through them. Okay, so grab that sheet of paper and let's get ready to go over some of these. Okay, what we're going to look at here, and we're going to go over several practice problems. Feel free to pause, move forward, skip things. I encourage you to try to solve them on your own and then go back and compare to how I do it and see if you got it right. But I want you to follow these steps every single time. And when you upload the photos of your assignment, this is how it needs to look. The first thing that I think is most helpful when you're solving these is you look for the word what. Okay, you look for the word what. It's going to say, what is the new volume? What is the new pressure? What was the old temperature? The question is what. I want you guys to write down. Is it what is the new pressure? What's the new volume, etc.? And I'll show you how to do that in a minute. So that lets you know, what are you solving for? What's X going to be in this particular problem? And that lets you figure out what in the world equation, because the first problem you got to go through here is, what equation are we going to use to do this? Okay, the second thing I want you guys to do is underline or put a box around whatever you have. So whatever they give you, I want you to take it and put a box around it. So the first one that we're going to look at to see how that works is on this page, this Gas Law Practice Problem Mixed Review. And I'm going to keep this page right here with me. So I have all of this information up here at my disposal. I'm going to move it off to the side. Okay, so I'm going to look, and I've put a few on here for you guys to skip, but I want to look at, right off the bat, I want to look at number 10. And these go in no particular order, but that's kind of how your quiz is going to be. Okay, so for number 10, what I want you guys to figure out, it says, the pressure in an automobile tire is 1.88 atmospheres at 25 degrees Celsius. What will be the pressure if the temperature warms up to 37 degrees Celsius? So the first thing I told you guys to look for is the word what. Okay, so here it is. What will be the pressure? So what do we automatically know we're solving for? Pressure. We're looking for pressure. If the temperature warms up to 37 degrees Celsius. So let's go back here. We know we're looking for pressure. The pressure in an automobile tire is 1.88 atmospheres. Okay, that means that is your starting. The pressure in the tire is 1.88 atmospheres at 25 degrees Celsius. So this is going to be pressure, and this is the temperature at 25 degrees Celsius. So this is our temperature. So you've got pressure 1 and temperature 1. So let's go back to our list. We know we're looking for pressure, and they are giving us a temperature warms up to 37 degrees Celsius. That's another temperature. The temperature has warmed up too. So that means, is that the starting temperature or the ending temperature? That's the ending temperature. That's where it warmed up, right? Like later in the day kind of thing. Okay, so this is going to be another temperature. So let's go back over here and go, okay, well, we've got pressure and we've got temperature. Which one of these laws over here is going to give pressure and temperature? That's pressure volume. This is volume and temperature. This is pressure and temperature. So which one are we going to use? Gay-Lussac's law. So we're going to use P1 over T1. The 1 means where you start. So this is our initial or starting temperature and pressure, and this is our ending temperature and pressure. And these are just fractions. It's the pressure over the temperature and the pressure over the temperature. So in other words, the starting here equals the ending here of the relationship of these two things, okay? So what we're going to do is figure this out. The first thing I want you guys to do, the law used is Gay-Lussac's law. You can put GLL if that works. And I expect you guys to write down over here so you don't make any mistakes. P1 over T1 equals P2 over T2. Now all you have to do is go back and fill in for those things that you have. Okay, so let's go back over here and go, it says, what will the pressure be? So I'm assuming that's going to be like later in the day. What's the pressure going to turn out to? So let's go back over here and go, okay, well, what's our starting pressure? Our P1 is going to be 1.88 atmospheres over T1. What was our starting temperature? 25 degrees Celsius equals P2. So I look down here. Do I know P2? No, they didn't give me that. So P2, I'll do P over there. Over, later in the day, the temperature is going to be 37 degrees Celsius. Okay, so now we have everything that we need. We're just missing that one part. And there's a couple of different ways that you guys can solve that, whatever you're most comfortable with. I grew up doing this, and my preferred way for most of my students in the past, although I hate that I'm not there to ask you guys right now, is to cross multiply. So I cross multiply, and then I just solve for X, or in this case, I solve for P, right? So what we're going to do is do 1.88 times 37 and 25 times P. So that's going to end up being 25 times P equals 1.88. And if you plug that into your, can you guys see that? If you plug that into your calculator, it's going to be 1.88 times 37 equals 69.56. And so now what do you do in order to solve for P? Got to get that by itself, right? So you divide it by 25, and that cancels it out. But whatever you do to one side, you also have to do to the other. So we're going to divide that by 25. So my answer here, 69.56 divided by 25 equals 2.78. So that means P equals 2.78. You're not quite done. You did solve for P, but go back and go, okay, first of all, are those numbers kind of similar to one another? Was my pressure in the beginning kind of a smaller decimal? It was 1.88. So was it? Yes. And what unit did they use? In this case, they used atmospheres. And mine got a little sloppy, sorry. You know I write really big. And your answer is P2. That's your second pressure equals 2.78 atmospheres. That's it. You're done. Okay. So if you go through those steps, you'll have fewer problems. So you used the what, you found out what you're looking for, and then you figured out what problem it was that you were looking for. Okay. Number 11 is a combined gas law problem. So if you're looking at number 11, I want you guys to skip number 11. You can use that space up there if you need to use that space up there. If you write huge, like I always write. So I'm going to put an extra sheet of paper there because I write too big. So now let's look at number 12 on here, and let's figure out what kind of a problem number 12 is going to be for us. So you've got number 12. It says a sample of oxygen gas occupies a volume of 250 milliliters at 750 or 740 torrs of pressure. What volume will it occupy at 800 torrs of pressure? Okay, sorry, and I should have put that on y'all's paper earlier. I didn't. If you go back to your cheat sheet or your fact sheet here, atmospheres or torrs, okay? They did say that, though. They say torrs of pressure, so they're telling you. So the first thing I want you guys to do is find what volume, okay? So we're going to be solving for volume will it occupy at 800 torrs of pressure. So we know we've got volume there. We've got 800 torrs of pressure, so we know that's a pressure measurement. And then if we go back to the beginning, they give us some information here. A sample of oxygen gas occupies a volume. That means takes up a volume. Here's volume of 250 milliliters at 700 torrs of pressure. So this is where we're starting, and it wants to know where you're headed. Okay, so this is going to be 2 and 2. The two are always related. Okay, so let's go back and look at our list now. We got volume and pressure. That's it. No temperature on there anywhere. So let's go back and let's look. Which one of these over here is only volume and pressure and nothing else? Volume and pressure, nothing else? I think we have a winner. So this is going to be Boyle's Law. Okay, so now we're going to go back and let's just really simply set this problem up. You need to copy over your equation, which is P1 V1 equals P2 V2. What do you guys know about when you guys have an equation and they're side by side like that instead of being in a fraction? What function is that? It's multiplication. Okay, so that means P1 times V1, whatever that number comes out to be, equals the multiplication of the second pressure and the second volume. Okay, so let's look down here. Now we just need to plug it in and play with it. I call that plug and play. So now we need to look at our plug and play situation down here. What's our first pressure right here is going to be 740 torrs. I use parentheses to keep up my numbers. Okay, 740 torrs. Then we're going to multiply that, and I'll scratch that out so I don't confuse myself. We're going to multiply that times the volume, which is 250, equals pressure 2 times volume 2. Do we have volume 2? No, but we do have pressure 2. Pressure 2 is 800 torrs, right? So it equals 800 torrs times volume. That's what we don't know. So what do we do to solve it? Well, you have to, again, get that number all by itself. So the first thing that we're going to do, let me clear that out. First thing we're going to do is multiply over here. 740 times 250 equals 185,000. 185,000 equals 800 times V. So what do we do to solve for 800 times V in this situation? How do you get 800 by itself? Well, you do the opposite. You divide. So we're going to divide this by 800, and that's going to cancel those numbers out. And then whatever you do to one side, you have to do to the other. So we're going to divide this out, and we're going to do 185 grand divided by 800. So take that 185 grand, divide by 800. It gives me 231.25. Now, am I done? No. First of all, what did I solve for? What variable was missing up there? Volume. Okay, so volume equals, and then make sure you have a unit. Go back and figure out which unit it was. So it says, what will the volume be if the pressure is at torrs? Well, what was our unit for our volume over here? Milliliters. And then put a box around your answer so that I know that you are finalized and that is what you believe to be your final answer. Okay? So next question we need to go over. So that means we've done an example of, we did Gay-Lussac's law, we did Boyle's law. Now let's look at our handout here, and let's do number 13 since we're down here at the bottom, and I have put on there for you guys to skip 14 as well. So let's look at 13. Number 13 says a child receives a balloon filled with 2.30 liters of helium from a vendor at an amusement park. The temperature outside is 311 kelvins. What will be the volume of the balloon when the child brings it home in an air-conditioned house at 295 kelvins? So the child is at the park and gets the balloon, and the temperature out there is 311 kelvins. I'm sure none of us have any idea what that feels like, but hey, whatever. So if you're a kid, you guys probably know already what's going to happen to this balloon. So the question that we're looking for is the word what. We're looking for the word what. Here it is right here. what will be, that means later on in the day, what will be the volume of the balloon when the child brings it home in an air-conditioned house? In other words, it must have been hotter where they got this balloon. Now you brought it home to your house, which thankfully is cooler. Okay, so let's go back. We know that we're going to be looking for volume. That's definitely something we're dealing with. Let's go back and figure out the rest. A child gets a balloon filled with 2.3 liters of helium from a vendor at an amusement park. The temperature where the amusement park is 311 kelvins. That's another temperature. So far we have volume and we have temperature. What will be the volume when the kid brings the balloon home to a house that's only 295 kelvins? So what are we dealing with so far? We're dealing with volume of a balloon, and we're dealing with the temperature of the outside versus the temperature of the house. So let's look over here. Volume and pressure. Is that it? No. Volume and temperature. Could that be it? Yes. And it's not pressure and temperature. So which law is this going to be? Charles's law. And you've got your starting volume and your starting temperature compared to your ending volume and your ending temperature. And by volume, we're talking about those of us that put balloons on our mailbox at the end of the day, and we're like, dang it, our balloons are all, crumpled up and small looking. What happened to our balloon? Well, that is what happened, except it's the opposite. This kid's going from hot air to cooler air. A balloon sitting outside in Georgia is going from cooler air to hotter air as the day goes on. So what we're going to do is we're going to copy this law down. So our law in this case is going to be Charles's law. And then it's V1 over T1 equals V2 over T2. Okay, V1 over T1 equals V2 over T2. So now just go back and figure out how you fill them in. What's your initial volume? 2.3 over 311 kelvins equals, we don't know our second volume, right? That's what we're solving for. So V over the second temperature is 295 Kelvin. And you're going to do the exact same thing again. You're going to solve for that. So go ahead and type that in your calculator, cross multiply, and set that up. And after you've cross multiplied and you've solved for V, you're going to end up with V equals 2.18 liters. And just double check yourself. Go back and go, okay, well, I came up with a pretty small number, pretty small decimal, right? It's not like I came up with 30 million or something. So let's go back and look. What was our starting volume of this balloon? Which a balloon's pretty small, right? The starting volume is 2.3 liters. So 2.18 liters. Is that in the same ballpark? And the answer is yes. If I had ended up with some crazy number, like I started with 2.3 and ended up with 20,000, I should probably double check my math, make sure I was right. Okay. All right, the last thing I want you guys to do is switch out that paper for, this is the last or next to last paper in your gas laws combined packet. It's a PDF. It's got all the different gas laws. It starts with Boyle's law, Charles' law, Gay-Lussac's law, all that. Okay, this is the next to last one. This is the ideal gas law. We're going to do one of these on here so that you guys can make sure. This is the only one that doesn't have like a 1 and a 2 or before and an after of the two different things. Everything else was pressure and volume, pressure and temperature, or volume and temperature. You never have more than two variables. So if you get a problem and you're like, whoa, it's got all these different variables in it. It's got more than just pressure and temperature. It's got more than just two things. It's your ideal gas law. Okay. So again, the hardest thing is figuring out which law you're looking at. So if you get a problem, and I'm cheating because I told you guys this is an ideal gas law problem, but if you guys get a problem and you're looking at it, and it says your noise level at sea, your nose is at sea level and has 2.3 atmospheres of pressure. So 2.3 atmospheres of pressure at 354 Kelvin. That's pressure. Kelvin is temperature, okay, with 0.050 liters of volume, okay, so that they just told you that's volume. Already, I've got all three of those things in there, right? So if you've got all three things in there, you automatically know that's more than two. So this has to be ideal gas law. How many moles of air particles are in your nose? So they're asking you guys how many moles of air particles are in your nose. And moles is the little n up there. Okay, so P is pressure, V is volume, N is moles, and then R and T. And so on your test, we actually give you the R value all the time. R is the constant. And R, so let's see. Let me just have you guys write this down. P is pressure. V is volume. And then on the other side of that equation, you're going to have N is moles, R is the gas law constant, and that is 0.0821. It's up here, 0.0821. And on your test, we included that in the problem. You guys never have to solve for that or figure that out. And then T, as you guys know, over here is temperature. Okay, so that's what those stand for. When in doubt, plug in the ones you know, solve for the one you don't. If it says in parentheses that R equals 0.0821, well, that's what R means. Okay, so now what we're going to do is look at plugging this in. So obviously we know because we've got pressure, temperature, and volume, and the question says moles. If it ever says moles, it's an ideal gas law problem. So this one says moles, so let's solve for that. So it's going to be P first is 2.3 atmospheres times volume is 0.050, 0.050 equals, make sure you're keeping them in the right order, don't just go through the problem, equals N, and it says how many moles. So do we know what N is? No. So N, the next one is R. R constant is up here, and it'll be written right beside it in your test, 0.0821 times temperature, and we know temperature is 354 kelvins. So what do we do now? Well, we've got to just solve for it. It's just like any other math problem. I've got a whole bunch of numbers here, and I've got a variable by itself. So I'm going to have to solve for that. So go step by step and do that. So you've got multiply these together and multiply these together. So once I multiply those together on this left-hand side over here, I got 0.115. And on this side, I have N, because I still haven't solved for that, but I multiplied these together, and I got 29.06. Now I need to solve for N. In order to solve for N and get it by itself, you have to do the opposite. N times this, the opposite is division. So we're going to divide it out, divide this by 29.06, and divide this side by 29.06. And once I divided those out, canceled those out, divided 0.115 by 29.06, and I got N equals 0.0039. And it's moles, 0.0039 MOL. Okay, so that's about it for this section. Make sure that when you guys get ready to take your quiz, you have your entire handout here with you. Make sure that as you do your work, you show your work. Make sure you read the directions to see which questions you need to actually solve, because I solved a lot for you, and I don't need you guys solving every single thing in here. That's not a good use of your time. And then hopefully I'll see you guys in Zoom on Friday so that I can kind of communicate with all of you guys. It would be great if you would all show up for that. All right, let me know what questions you have. Thanks.